Our next topic is sparse matrix. A matrix in which there are more number of zero elements are there. I have an example matrix of order 8 by 9, and you can see that it is having very few non-zero elements like 3, 8, 10 and 4, 2, 6, 5, 9. There are very few non-zero elements. If I count 1, 2, 3, 4, 5, 6, 7, 8, only 8 non-zero elements are there. Mostly in statistical data or survey data, data may be represented in the form of a matrix and there may be a lot of zero values. If so, then if we are using sparse matrices in our program, then we may be having a lot of zero values for which we may be wasting space and also processing time. So again, the same thing, we want to store a matrix in less amount of space and the processing is also less. So what we should do? We should store only non-zero elements. So for storing non-zero elements, there are more than one approach available. One method is coordinate list and the second one is compressed sparse row. So these are two representations, coordinate list and compressed sparse row. And this coordinate list is also called as 3-column representation. So first we will see coordinate list or 3-column representation. For coordinate list, for every non-zero element, we need 3 things. First is its row number, second is column number and the element itself. So for 3, row number is 1, column number is 8 and the element is 3. For 8, this one, row number is 2, column number is 3 and the element is 8. So we will have a tuple of 3 values, that is row number, column number and the element. So we can have the list of tuples, so we can call them as coordinates, or we can represent them in the form of columns, that is 3 columns. First column is row and the second column is column number and the third one is element itself. Now let us represent those non-zero values in these 3 columns. So first non-zero value is 1, 8, 1, 8 and 3. I have left the first row blank, so at the end I will show you what is the use of that first row. Then 8, 2, 3, 8, 2, 6, 10. Then 8, row number is 2, column number is 3, element is 8. So 2, 3 and 8. Likewise, I will fill up all those non-zero elements. So here I have filled 3 columns with row number, column number of each element and the element itself. Now in this one, first row I left it as empty, that I can use it for storing information about the sparse matrix. So about the sparse matrix means what are its dimensions? 8 rows and 9 columns. 8 rows, 9 columns. Then how many non-zero elements are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 non-zero elements are there. So first row we can use it for number of rows and then number of columns and number of non-zero elements. So this is a commonly used method. Using this method, I will show you how to perform addition and subtraction of matrices. But before that, let us look at the second method, that is compressed sparse rows. Now second method, compressed sparse row. In this method, a sparse matrix represented using 3 arrays. So the first array is list of non-zero elements. I will write down non-zero elements. 3, 8, 10, 4, 2, 6, 9 and 5. So this is a list of non-zero elements. I have taken all those non-zero elements in the same order in which they are appearing. Don't change the order, like first 8 then 10. Don't change the order 10 and 8. Next, we need an array for rows. So this is important one, just watch it carefully. So we will have an array of rows. In this, the very first thing is 0. The very first value is 0. So initial value is 0. Our indices are starting from 1 onward. So this is for 0th index. 0th index. Then next, in first row, how many elements are there? 1 element is there. First row. This is for row number. Then in second row, how many elements are there? Second row, 2 elements are there. Then plus 1, that one also. So we'll write 3 here. So this 3 is nothing but 2 elements in the next row plus 1. So this will take the cumulative of number of elements. Initially there is 0. Then first row having 1 element. Then till second row, total 3 elements are there. Then in third row there are no elements, so it should be 0, but this previous number we will take it. So this shows that 3 minus 3 there are 0 elements here. 3 minus 1 there are 2 elements here. So we'll take the cumulative of the number of elements for each row. Even I will write down the indices for row number. This is for 0th row, there is no 0th row. This is first row, this is second row, and this is third row. Then in the fourth row there is 1 element, so it is 4, one more. In this 3 plus 1, that is 4. So this is for fourth row. Then fifth row there are no elements, so let it be 4 only. Then sixth row there is 1 element, so this will be 5. Then seventh row there is 1 element, then it will be 6. Eighth row there are 2 elements, then this will be 8. So this is for fourth row, fifth, sixth, seventh, and 8th. So for every row will contain the number of its own elements plus the value in the previous row. Then the third one is column array for j values. So this is JA. Now this element is present in 8th column. This is corresponding to the element. This is in 8th column. Then this is in third column. This 10 is in 6th column. 6. For every element we will have a column number. This is in first column, and 2, this is in third column. Then 6 is in fourth column. Then 9 is in second column. Then 5 is in fifth column. So as many elements are there, that many columns are there. But here as many rows are there plus 1, because starts from 0 onwards. So this is another method that is called as compressed sparse row. Let us analyze this little bit upon space. This is a sparse matrix of 8 cross 9. Total 72 elements including zeros, that is zeros and non-zero. Together there are 72 elements. And if each element is an integer and is taking 2 bytes, so this is 144 bytes. So if we focus on the number of elements, that is sufficient. But here, how much space is required? 8 non-zero elements. Then this one, 8 non-zero elements. Then what about this one? Total 8 rows are there plus 1, so this is 9. So this depends on number of rows, and this too depends on number of non-zero elements. So total how many elements are there? 25 elements are there. Then if all these are integers, then require into 2 50 bytes of memory. So that is 144 and this is 50. So almost it is 30% of that space. So 70% of reduction in the size of memory. So 30% of memory is reduced if you are following this method. So similarly in the coordinate list or the 3-column method also the memory is saved. Now I will take 2 small examples of sparse matrix and show you how addition of sparse matrix can be done. Let us look at addition of 2 sparse matrices in coordinate list representation. Suppose I have sparse matrices like A, B, and I want to add these two and get the result in C. So this is in mathematical form. But when it is represented in a program in the form of a coordinate list or 3-column method, whatever it is, for that how we perform the operations, like addition operation we will see. So first of all, I will solve it manually, that is using pen and paper. Think that using pen and paper, how I can add these two and what should be the result. So let us do it. The dimension of first matrix is 5 by 6. Second matrix is also 5 by 6. So yes, they can be added. So for adding 2 matrices, their dimensions must be same. Then the third matrix I have already taken here the size 5 by 6. Now what are non-zero elements in first matrix? 6, 7, 2, 5 and 4. And the non-zero elements are 3, 5, 2, 7, 9, 8. Now, a normal procedure for adding two matrices, we will run the same method. That is, every element of A is added with the corresponding element of B matrix. So let us add them. So let us start with first one. First element is 1, 1. 1, 1 here. 0. 0 plus 0 is 0. Then 1, 2 with 1, 2. This is also 0. So I will do the rest. This is 0 and 0. So this is 0. This is 6 and here it is 0. So 6 plus 0 is 0. Then remaining 2 are 0, remaining 2 are 0, 0. Now second row here we have non-zero elements. First is 0 and next is non-zero. And here we have 0 and non-zero. So this is 0 and this corresponding elements, they are at same index I and j. So 7 plus 3, this becomes 10. And the next element is 0, 0 and here we have one more non-zero for which there is 0 here. So it will be just 5. So 0, 0, 5, 0. Then third row 2, 5 and here there is 2 here. So this is 0, 0, 2 plus 0, 2 only, 0 plus 2, 2 only, 5 plus 0, 5 only, then 0, then 7. So if I take them, first one is 0, then 2 as it is, 2 as it is, 5, then 0, then 7. Then fourth row, all are zeros here. So 0 added with these will get the same thing. So we will get the same row. 0, 0, 0, 9, 0, 0. And the last row, 4 and then here 8. So this is 12. And rest of all zeros, here also rest of all zeros. So these are all zeros. So this is what the addition of two sparse matrices A and B, and I got the result C. So C is obtained by adding A plus B. How many non-zero elements I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 non-zero elements I have. Now let us do the same thing using coordinateless representation. Let us represent this as a coordinateless. So in this sparse matrix, let us count the number of non-zero elements. 1, 2, 3, 4, 5. 5 non-zero elements are there. So I will take a horizontal table of size 6. Let us call this as A. So it may be a two-dimensional array or array of terms. How to implement it in programming, we will discuss afterwards. So at 0th index, I will write down the dimensions, that is 5 rows and 6 columns, 5 rows and 6 columns, and the number of elements 1, 2, 3, 4, 5 non-zero elements. Now let me fill this table with the non-zero elements. So first row, there is element 6 at column 4. First row, fourth column, value 6. Second row, second column, 7. Second row, second column, 7. Third row, fourth column, 5. Third row, fourth column, 5. Fourth row, there is nothing. Third row, second column, 2. Third row, second column, 2. Then third row, fourth column, 5. Third row, fourth column, 5. Then fourth row, there is nothing. Fifth row, first column, 4. Fifth row, first column, 4. This is how it is represented. Now second one, I will do it quickly. So I have a representation for B matrix also, which is having 5 by 6 dimension and 6 non-zero elements, and all those elements are here. Let us see how addition can be done. We have to add these two matrices from this representation. So we need one more array of coordinates, that is the same type of array for C, but we don't know how many elements it may be getting. So what should be the size? See how many elements here? 5. How many elements here? 6. Total 11. If none of them is matching and none of them is added, then at most 11 elements are required. So I should have space for 11. But I will not take 11. We know very well. Answer we know. So how many non-zero elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the size. So I will take the size 9. Then I will add it from here. I have a array ready here. Now let us start adding them. The dimension are 5 and 6. I don't know how many elements I may be getting. Once I get the number of elements, I will update this one. So let us start adding. So for adding, I will go on the first term of this one and let us say I, and this first term of this one, let us say j. See, this 0th index is having the dimension and number of elements. Now let us start how to add them. First check the row number here and row number here. That row number is smaller. So that element comes before this element. They are not in the same row. So that first row 1 element comes here. So we'll include that element here. Directly it is included. So you can see that here we wrote directly 6. 6 directly came from here. So same thing, it's not added with anything. Then as we have copied this element, move to next element. Compare rows. Rows are same. Compare columns. Columns are also same. So these are matching. So add 7 plus 3. So row number is 2, column number is 2, and add them. And move I also and move j also. So this is what we got 10 here, because the 7 and 3 were matching. Now next element, row number 3, row number 2, this element come first. There is no matching of rows, so directly take this element, smaller row number, copy it here. Then move to next. Now row number 3, they are matching. Column 2, column 3. So this element come first. So they are not matching, but this element come first. So take this 3, 2, 2. So 3, 2, 2. See, this was the element. This was the element. Then move to the next element, I. We are here, 3, 3. Row numbers are matching again. Now check the column number. Column number here is 4 and here is 3. So this element come first. So 3, 3, 2. This is the second element in that row. Then move j to next element. Now compare row number 3, row number 3. So same row number, but column number, this element come first. So 3, 4, 5. So 3, 4, 5. 3, 4, 5. This one. Then as we have copied this one, move to the next element. Row number 5, row number 3. So this element is smaller. So this will come as it is. So 3, 6, 7. Then move next. Row 5, row 4. So this is smaller. 4, 4, 9. Then move next. Row matching, column also matching. Oh, they are in the same place. So add these two elements. So this is 5, 1 and 4 plus 8, 12. So this is how we can add by scanning through array A and scanning through array B. And if the rows are matching, check for the column. If that is also matching, then add them. If row is small, directly copy it. If column is small, directly copy it. So that's all about sparse matrix, and the operation like addition I have shown you. So similarly, you can do subtraction. So how it can be done through a program, I will show you that. In this video, we'll learn about sparse matrix. So these are the things that I'm going to discuss. How to represent this in our program, then how to create this sparse matrix. Instead of this, we will be representing like this. Instead of two-dimensional array, how we represented it as a coordinate list or a 3-column method. Then next, I will show how to add two matrices. So we will write on the code here for creation and addition. Then the complete program, I will write the program and show you. The complete program we will look in demo video. Now let us start with representation. In this example sparse matrix, this is of dimension 4 cross 5, that is 4 rows and 5 columns. There are 5 non-zero elements, 1, 2, 3, 4, 5. So this first tuple is about dimension and number of non-zero elements. Then these are all non-zero elements, like the first element is at first row and third column and the element is 7. So first row, third column and the element is 7. So for each element we require 3 things, that's its row number, column number and the element itself. So I am calling them as I, J and X. So for one single element we need 3 values. So we can combine these 3 values and we can define a structure. Let us define a structure called element. Struct element. That element is having I as a row number, J as a column number and integer the value element itself. These are the things that defines a single element in a sparse matrix. So for this we need a array of elements in a sparse matrix. 1, 2, 3, 4, 5. 5 elements are there, so we need an array of elements. As well as we need dimensions, that is m and n and number of non-zero elements. So let us call these dimensions as m cross n and also number of elements. So let us define a, so let us look at again what are the things that we need. We need m, n and number of elements and the list of elements. So let us define a structure for sparse matrix. Struct sparse. This is having m for number of rows, n for number of columns. Let us call it as num for number of non-zero elements. That is this one, number of non-zero elements. Total 5 non-zero elements are there. Then, so these three things are defined here by these three variables. Then rest of the elements we can define as array of these elements. So struct element E. I need an array. So shall I declare it as an array of some size? If I declare an array of some size, then it will be limited. It will be for only those many elements. Then instead of taking as static size array, let us take it as a dynamic size array. So for that, I'll just keep it as a pointer. So E is set of elements, that is a pointer. Then dynamically we will create this array. So that's all. This is the structure for sparse matrix. Sparse matrix, let us read it again. A sparse matrix structure is containing number of rows, number of columns, number of non-zero elements and the array of elements which has to be created dynamically. Now let us see how to use this structure and create a sparse matrix. So I'll remove this and use this space. Now let us look at how to create this sparse matrix. So for that I will write a function. So first let us say that I have a main function, and inside main function I have created a sparse matrix object. So struct sparse S. This is one of the sparse matrix. This is one sparse matrix. And like this, if you want more, you can take more sparse matrices. So I have taken just one. So S is a sparse matrix. If you look inside S, what are the things it is having? So S is having M, that is number of rows, N, number of columns, and num, that is number of non-zero elements, and E, that is a pointer which can hold a list of elements. So this is M, N, number of elements, and E is a pointer for list of elements. So this is how I got a structure, an object. Let us call it as object. Now I will have a function called create. So let us call a function as create, which will send this structure by reference. Now here I will write down that create function. Void create. This function takes a structure type pointer, so that is sparse matrix type pointer, struct, and let us call this pointer as S only. So this function is having a pointer S which is pointing on this one. So this function can access this structure which actually belongs to main function, that is sparse matrix structure. Now what I am going to do in this create function, I am going to fill all these values, that is number of rows, number of columns and number of non-zero elements, and I will take all the elements and fill up them. So I will write down the code for all those things. So let us write the very first thing. I want to know how many rows and how many columns are there and how many non-zero elements are there. So let us ask it and take it from keyboard. Printf enter dimensions. Then read dimensions. What are those? M and N. These values I want to read them. So I will be reading them through this S. So I will store the values here. See, I am reading two values. Ampersand S arrow M, S arrow M. Then ampersand S arrow N, S arrow N. So this actually belongs to main function, but this is being filled by this function. So both the values m and n are stored. Now I need to know how many non-zero elements are there. So printf enter number of non-zero elements. So enter number of non-zero. I have just written non-zero. So we want non-zero elements. Now scanf read the number of non-zero elements and store in this one. So scanf ampersand s arrow num, s arrow num. Let us read it as a caps. Actually this is not a cap symbol, but s caps num. Actually caps symbol means this one. This is caps. But this arrow, instead of using term arrow, I feel comfortable calling it as caps. So s caps num. So reading the number of non-zero elements. Now suppose the values that are filled according to this example, this is 4 number of rows and this is 5 number of columns and this is 5, that is number of non-zero elements. Then what should be the size of this array? I have to create this array dynamically. I should have an array of those structure of size 5. So let us create an array of size 5 elements. So I have to take the objects of elements and make an array of elements. So let us write on the code s caps e assign. I have to create an array of elements of size 5. And this is pointing there. So this is I and j and x. I should have an array of size 5. For creating that, we have to dynamically allocate the memory. For that, we have to use malloc function. But I said that I'll be using new operator of C++. That is easy to write. It will reduce the size of the code. Already we have discussed how to write malloc function. Let us write new. New array of what? Array of elements. Of what size? The size is here, the number of elements. So say s caps num, whatever the number we have taken. So this will create this array of elements. So this is ready. Then I have to fill all these elements one by one. So I can say enter all non-zero elements and I can read all of them one by one. So for that I can use a for loop and read all of them one by one. So let us write the code here. Printf enter all non-zero elements. So printf enter all elements. And these elements each will be having row number, column number and the element itself. So I have to read all 3 values for each element. So I can use a for loop and read all of them. So for that I may need some variable like say I for running a for loop. So for I assign 0, I is less than number of elements. So this is s caps num and I plus plus. Then inside the for loop I have to read all the elements. Now already we have understood how a main function can create an object of a sparse matrix and call it for creation. Now same way from main function we call for addition, subtraction, whatever we want to do. So I will remove this main function and I will finish the code for creation. So here we have to read 3 values. So scanf. See, I have to read 3 values. Scanf %id, %id, %id. I have to read all these values, 3 values. So here I have written just one. Ampersand s caps e of I. So I is starting from 0 to num. So I initially this is 0. Then dot I. Here we have the row number and column number. Dot I. This one. Then ampersand is there. So its address. So at this place value will be written. So the first value enter from the keyboard. If it is 1, then 1 will be written. Then likewise I have to read other 2 values also. So there is no space. I'll just write below this one. So s caps e of I dot j ampersand s caps e of I dot x. This is how I can scan all 3 values. So that's all. This is a create function. Next we will see how to add 2 sparse matrices. So for that I'll just write the function, the code for adding 2 sparse matrices using the same representation. In this video we will develop a C language program for sparse matrix. Already what we have discussed on whiteboard, the same thing we will write the program and look at the demonstration. So for that I'm starting a new project and the project name I will call it as sparse matrix. The language selected is C language. Next, create a project. Project is ready and this is the main function. I'll remove these comments. Yeah, we are ready with the main function, empty main function. I'll remove the panels. Now let us start. As we have discussed on whiteboard, for implementing a sparse matrix, we will define a structure for non-zero element. So I will first define a struct for element. This is representing non-zero element. So this is the row number and column number and element. So I is for row number, J is for column number, and X is for non-zero element. Then the next structure we saw was sparse. I'll call it as sparse. And the next structure we saw was sparse. In this sparse structure, we need the dimensions of a matrix, that is M, that is number of rows, number of columns, and we also should know the number of non-zero elements. So for that we have taken a variable, that is num, a data member num. Then we need array of elements. So for that structure element, and I will take a pointer, that is le, so that we can create an array of elements. Whatever the number of non-zero elements we have, we will create an array of that size and we will create it dynamically. Now structures are ready. Then first function I have shown you was for creating a sparse matrix. So I will write a function for creating a sparse matrix which takes a structure of sparse. It will take call by reference. So let us call it as S because it has to modify the structure. Now here I will take all the inputs from the keyboard, that is what are the dimensions and how many non-zero elements, and also I will read all the non-zero elements. So for that I may require some variables. I will declare them afterwards. Let us first take the input, that is dimensions. So for that I will say printf enter dimensions. Then scanf, I should take two inputs, that is number of rows and number of columns, ampersand s arrow m, ampersand s arrow n. So these are the dimensions of a matrix. Then I should also take the number of non-zero elements. I'm making a message simple, number of non-zero. So number of non-zero elements, that is, so scanf s caps num, that is s arrow num. So I know the number of non-zero elements also. Now, as we know the number of non-zero elements, we must create an array of elements here dynamically from heap of required size. So how many number of non-zero elements I have, it is given here. So that should be the size of an element array. So here, next line, I will create an array of size num. So scaps ele assign. I should call malloc function for creating an array of some size. So what should be the size? S num should be the size. And this size should be multiplied by the element. So it should be array of elements. So I should say struct element. Then as malloc function returns void pointer, I must typecast it of type element. So this will create a array of size num, and array will be of type elements. It will be creating in a heap and this ele pointer will be pointing on that one. Then as I have used malloc function, here in the top I should include the header file for it, that is stdlib.h. Now back to the create function. I have an array, then I should take all non-zero elements. So I will say printf enter all non-zero elements. Now there are more than one non-zero elements. I should read them using for loop. So for that I will take a variable I starting from 0 as long as I is less than number of non-zero elements and I++. I will directly scan the values. So now for scanning I should read three values, that is row number, column number and the element. So I will take all those values. S of element of I dot I. The next is S of element of I dot j. This is the second dimension. Then S dot element of I dot x. This is the non-zero element itself. So that's all. It will be reading all non-zero elements. As I have used one variable, that is I will declare the variable I also here. Create function is ready. Now I will write one function for displaying sparse matrix. I will display it as a matrix. I will show zero elements as well as non-zero elements. Both the elements I will show, not just non-zero. I will display zero elements also. So let us have a function for display. Display function should take a parameter of type struct sparse matrix, and call by value is sufficient because it's not going to modify the matrix. And for displaying a matrix, we require two dimensions. So for that, I need two for loops. So I and j, as well as for non-zero elements also, I will take k. And this k, let us initialize with 0. Now using two for loops, we know how to display a matrix. So same code I will write down, two for loops. I is less than s dot m and I plus plus. Then for j assign 0 and j is less than s dot n and j plus plus. This is for two for loops for displaying a matrix. Now here I should display a non-zero element if I is equal to s dot element of k. K will be tracking the elements and it's I. As well as j should also be equal. So j should be equal to s dot element array kth element and its j dimension. If these two are matching, that is I and j are matching, then I should print an element with a space s dot element of k dot x, the element I will display. And also I should move to the next element in the sparse matrix. And if this is not matching, then I should print 0. And I'll give you a space. As we have already written the programs for displaying the matrices, so after the first for loop, if a line gap is given, then it properly looks like a matrix on the screen. Let us give a new line. Yes, I have two functions ready. Now inside the main function, I will create an object of type sparse matrix S, and I will first of all send it for create function. Then I will send it to display function for displaying the matrix. Now let us first compile and if check whether there are any errors. Let us run compile. Yeah, there are some errors. So yes, see, I am showing you the errors also because I have just typed and maybe some mistakes. So you should know if there are any errors, how to remove them. Yeah, the first error is expected expression. So something we have missed here. Yeah, this should be size of struct element. Yes, perfect. Then here I have mistyped struct. The next is M is not a member of sparse. See, this is call by value. I have taken it as call by value. So this should be dot. It should not be arrow. And here also it should be dot. It should not be an arrow. Let us compile once again. Yes, all errors are gone. Now program is ready to run. Enter dimensions. I will take the dimensions as 5 by 5 and I will give 5 non-zero elements and I'll give elements in first column. So let us give the row number, column number and non-zero element. So row number, column number is 0, 0 and the element is 1. Then row number is 1, column number is 0 and the element is 1. Then row 2, column 0, element is 1. Row 3, column 0, element is 1. Row 4, column 0, element is 1. Yes, here it is displaying the entire matrix along with the zeros. It's working perfect. So we have finished with the creation and displaying of a matrix. Let us look at addition operation of two sparse matrices. So already I have discussed how addition is done, but now let us write on the code a function for adding two sparse matrices. So for example, I have taken two sparse matrices S1 and S2, and this is their representation. That's a structure called sparse. We have already seen it. So that these are the objects of sparse structure, and already I have filled. This is 4 cross 5 matrix, 4 cross 5. 6 non-zero elements are there, that are 1, 2, 3, 4, 5, 6 non-zero elements, and all the elements I have already filled here. Like this element 1 comma 3 is a 3, so 1 comma 3 is 3, or 4 comma 2 is a 6, so 4 comma 2 is 6. Similarly, I have filled this one also. Now let us write a function for adding these two sparse matrices and generating a third matrix, that is sum of two matrices. So already I have kept one pointer here. Now let us look at a function. Function name is add. It needs these two matrices. Now where these matrices are available, they are maybe present in some other function. So this function needs pointers to those two matrices. So I will write sparse. Actually, I should write structure sparse, but I am just writing sparse here. Pointer S1. So this is a pointer for first matrix. Then sparse pointer S2. This is the pointer for the second matrix. Now the function is taking two pointers, S1 and S2. Let us imagine that this pointer is pointing on this one, and this pointer is pointing on this matrix. So these are present somewhere inside, let us say, main function. Now it has to add those two. So inside the function, first of all, let us check whether these two matrices can be added or not. Whether they can be added or not, we can know it by comparing their dimensions. The number of rows, that is 4 should be same, and number of columns 5 means their dimensions must be same. So let us write on that first condition. So what I am checking here, if rows are not matching, columns are not matching, don't do anything. So first I wrote a code for checking this one. See, even I could have checked whether they are equal or this is also equal, then do all the operations. But the other way I have written, if they are not matching, stop, don't do anything. So first I have checked the false condition here, that is failure condition. If they are not same, then stop, don't do anything. Otherwise, they can be added. How to do that? So for adding, first of all, I should create a third object. So here already I have taken a pointer called sum. So for that I will create an object. So for that I should have a pointer inside this function, that is sparse pointer sum. So that is a pointer. So to that pointer I should create an object of sparse matrix having m, n, number of elements, and also a pointer e. I should have an array of some size. So what should be the size of this array? I should create the object, and also I should create an array of elements of some size. So first of all, let us create this object. So I should say sum assign new sparse object is created. Then here I should fill the dimensions. I can take the dimension from either S1 or I can take them from S2. So sum's number of rows m should be same as S1's number of rows, and in the same line I am continuing, sum's number of columns should be same as S1's number of columns. So this 4 and 5 I can copy that here, 4. Then how many number of elements? I don't know. Once I have finished adding, then I'll be knowing how many elements are there. So this I cannot fill up. Then this object I have to create. So what should be the size of this one? So unless I add, I cannot know what should be the size. But total maximum size I can have. So what is the maximum size? Number of elements here are 6 and here also 6. So total 12. So I will create an array of size 12. 12 may be more than the required size, but no problem. If you have some extra spaces that are unused spaces, no problem. So we will create assume that an array of size 12 is created. So I will mark few. Checking is completed. This is the way to check. Then creation of a new matrix, a sparse matrix is created, and we have created in heap. Remember this, we have created in heap so that it can be used anywhere in the program. If anywhere in the program you have a pointer to this one, you can access this one. So I have created this in heap, then I have filled these values. So let us create this array. For that I have to say sums e assign new. So what is that? Array of elements. So new elements. So element is one structure, we have already seen it. And what should be the size? So the size should be the combined size of S1 and S2's non-zero elements. So let us say S1's num plus S2's num. So this array is created. So we have finished with the initial work. So I cannot write everything here. I have to remove this, right? So just have a look of this function. I have a pointer here. Then I am checking whether their dimensions are not matching. Then stop there itself, return 0. Otherwise, create an object of sparse matrix. Then create array of elements and set the dimensions 4 and 5. So this much work is over. Now, further, I have to add them. So for that, I will remove this and write down the code for addition. Now let us write down the code for adding them. So for adding these matrices, we need index pointers I at the starting of this, j at the starting of this, and k. So I, j, k, all of them should be 0. Then let us see the procedure. See, first check the row numbers. If row numbers, among these row numbers, if S1's row number is smaller, then copy this one there. If S2's row number is smaller, then copy that one. So whoever's row number is smaller, copy that one. So first I'll check row numbers. See, if E of I dot row number, that is I. If you remember, these are I's and J's and these are X. So if this is less than S2 cap E of I, if row number of this one is smaller than that row number, then copy this element, that is this element, in K. So sum of E of K plus plus assign with this element. So all these three things can be copied directly. S1's E of I plus plus. So if this is small, copy this one. But in our example, they are equal. So if it is small, copy that one. Else, if S1's EI dot I is greater than S2's EJI, means if that one's row number is smaller, then copy that row number here. So sum of E of K plus plus is assigned with S2's E of J plus plus. So if first one is small, copy that one. Second one is small, copy that one. If both are equal, then what? Check column. So this comes as else part. Else. Now check column numbers. If this one's column is small, copy that one. If that one's column is small, copy that one. Otherwise, add them. So I have to continue the logic here. If S1's E of I dot j is smaller than S2's E of j's column, then copy this element first. So I will continue in the same line. So copy in sum of E of K plus plus, copy S1's E of I plus plus. Otherwise, if S1's E of j is greater than S2's E j of j, means this is greater than that one. Columns we are checking. See, these are columns. J are columns. Then copy this element there. So sum of E of k plus plus assigned with S2's E of j plus plus. So we have finished with the row is small or row is greater, column is small, else column is greater, otherwise both are equal. So this is in final else. We have to add these two and store the result there. So final else, I'll simply write on the code here itself. So sum of E of k plus plus is assigned with S1's E of. So for copying, I have to copy three things: row number, column number, and the sum of the elements. So for row number, column number, simply I will copy the values from S1, say S1 of I plus plus. So actually, I have simply copied S1, this element, to sum, but I should add them. So I should add the value from this S2, simply add the value. So I need one more statement. So after this, I should say sum of E, now say k plus plus, in this x value, I should add the value from S2. So S2's E of j plus plus dot x value. That's it. Then this procedure should be repeated. So this has to be continued while I is less than number of elements of this one, that is num, S1's num, S1's num, and j should be less than S2's num. So this loop will be comparing and copying the elements. I will just trace this code and show you a little bit. So let us trace the code. See, first row numbers are compared. Row numbers are same. So it will, so this is not smaller, this is not greater, so it will come to this else part. Then column numbers is checked. First one's column number is smaller. So this will be true at this point, this will be true. That is, row numbers of these two are same, but the column number is smaller. So 1, 3, 3 will be copied here. So 1, 3 and 3 is copied here. K is moved ahead, I is moved ahead. Now in this case, row numbers are checked. This is 2, this is 1. So this is false. So this will be true. So this roll number is smaller. So 152 is copied. So 152 is copied. Then j is incremented and k is incremented. So this was true in this case. So the element from S2 is copied. Let us continue. Now row numbers are equal, 2 and 2, but the column number is 1 and column number is 2. So again, this condition will be true. Column numbers, this condition will be true. So 2, 1, 4 is copied. So 2, 1, 4 is copied. K is incremented as well as I is incremented. Now this time 2 and 2 row numbers are same, but column number, this is greater, this is smaller. So row numbers are same means it will go into else part. But column number, this is greater than that one. So this will enter into this else part. See, this column number is greater than the column number of S1. S1's column number is greater than S2's column number. So S2 will be copied. This S2 will be copied. So 2, 2, 5 is copied. 2, 2, 5 is copied and K is incremented. J is incremented. Now this time, row number 2, 2 are same. So it will enter into else part. Then here column number 5, 5 are same. Then it will enter into this part, this else part. So it will copy the element from this one, that is 2, 5, 7. So 2, 5, 7. As I have copied S1's element, then I is incremented. It will move to next. But that value should also be added. So here I am adding in X, the value of this one, X is added. So it should be added plus a sign. So this value is added. 6 is added to this one. So this becomes 13 and K is incremented as well as J is incremented. So that's all. I have shown you all the cases. One time it was true here and it was true here also. And I have also shown you all three cases. Now similarly it will continue and it will add all the elements. So this type of code I will be writing in my program for adding two sparse matrices. Then at the end, whatever the value of k will be, so that will be set as the k value, number of non-zero elements. So that's all about addition of sparse matrices. We'll look at the program. So we have finished with the creation and displaying of a matrix. Now we have to write a program for adding two matrices that we have already discussed. So let us write a function for adding two matrices. The function name must be add. It must take two sparse matrices, sparse, and it can take them call by value or call by address. So I'll take them by call by address, though the function is not going to modify those matrices. Sparse pointer S2, two matrices it is taking. Then after adding, it should return a address to a addition matrix. So it will return a pointer to a sparse matrix. Now inside this function, I should also have one more variable for storing the addition of two matrices. So for that, I will take a pointer type object so that it is created inside heap. So first thing is a sparse matrix pointer I have taken. Then first of all, let me create the object of this sparse matrix. So sum assign, using malloc function, I have to create an object. So first of all, struct sparse pointer, then malloc function, size of, we are creating an object of sparse matrix. Yes. Then after creating an object of sparse matrix, I should also create an array for storing the elements. So this pointer, I should assign an array of elements to this one. So after adding total, how many elements may be there? At most, the number of elements will be equal to number of elements in S1 and the number of elements in S2. So for that, I should create an array of elements. So for sum of element should be assigned with an array of type element. So struct element pointer and malloc function, and the number of elements, as I said, it may be at most as at once number of elements plus S2's number of elements, and this should be multiplied with the size of a structure element. So size of struct element. Yes. So this line will create an array of elements for storing all non-zero elements in the summation matrix. Now I should write down the loop for comparing and copying the elements. So for that I require some variables like I, j and k, and I will initialize all of them to 0. I assign, j assign, k assign 0. Now as we have already discussed the procedure for comparing and copying the elements, so simply I will write down the procedure. While I is less than S1's number of non-zero elements and j is less than S2's number of non-zero elements. And while scanning through the matrices, we should compare their row numbers first, that is S1's element of I dot its row number if it is less than S2's row number, j dot I, that is row number. If this is less, then in sum of element of k, I should copy the element from S1, I, and I should increment both I as well as k. So this k is incremented as well as I is incremented. Now else if S2 is smaller, so I will write on this same code and modify it, these two lines. Now here, in the first condition we wrote if S1's row number is smaller. Here I will just modify this and say if S1's row number is greater. Then in sum of k plus plus, I should copy the element from S2 and this should be J. Yes, these two modifications I have done. And otherwise, if mean row numbers are same, then I should compare column numbers. So whoever column is smaller, I should copy that one. So again, I may require the same type of code, but with the column number. So I will copy that code and paste it here, and I will modify it for columns. See, here it was comparing row number. So this is J, column number now, and this is also J, column number. So if S1's column number is smaller, that will be copied. Otherwise, if S1's column number is greater than S2's column number, then S2 element will be copied. Now at last, this final else means both their row numbers and column numbers are matching. If both of them are matching, then in sum of element of K, I will assign the element of first matrix, element of I, then. So when I assign this, row number and column number will be copied. So instead of copying them individually, I am writing the entire element. So row number, column number as well as element will be copied, but element I will add it. Element of K plus plus should be assigned with S1's element of I plus plus its X value added with S2's element array of J plus plus X value. That's it. This will add both the matrices. Now this while loop will continue as long as I is less than S1 matrix and J is less than S2 matrix, and it will terminate when any one of the matrix has finished. So rest is simply I should copy the rest of the elements from the remaining matrix. So remaining matrix may be either the first matrix or the second matrix. So whoever index has not reached their end, I should copy them. So if I is less than S1's number of elements, I should copy all the elements from first matrix. So I will continue in the same line. Sum of element of K plus plus will be assigned with S1 element of I. I don't have to increment I because it's already incremented inside for loop. Now the same thing I should do it for second matrix also. So I'll copy this and paste it here, and I will modify it for second matrix. So this is J less than second matrix number of elements and J plus plus, K plus plus is as it is, and this should be copying from second matrix, and here it should be J. That's it. So this is the code for adding two matrices. And at last, for the sum matrix, I should mention dimension. So its M should be equal to any one of the matrix dimension I can take, that is S1's M, and sum of N should be equal to any one matrix columns I can take, that is same thing. Then this K is having the number of non-zero elements. See, K is tracking the number of elements that we are storing in non-zero elements array. So K gives the number of non-zero elements. So sum of number of non-zero elements, that is num, is equals to K, is assigned with K. So that's all. Now here inside the main function, I will have two matrices. Instead of S, I will take S1, then S2, as well as I will take S3. For S3, I should take a pointer because this add function will add two matrices and returns the address of a sum matrix that will be created in heap. It is creating in heap. So this is returned by address. So here inside the main function, I will create two matrices. First create S1, then create S2. Then we will call add function by passing address of S1 and address of S2. Then the result sent by this add function, we will take it in S3. Then to this display function, I will send all three matrices one by one so that we can see their results at once on the screen. Now before calling display, here I will give a message that printf we are calling showing first matrix. So this is first matrix slash n. Then this should be S1. Likewise, I will print the second matrix. So I will copy this code and paste it here. This is for the second matrix. Then this should be S2. Then after that, I will display sum matrix. New line. Then call display function by sending third matrix. Now third matrix actually is a pointer, so I should send it dereference to value of that one. So it should be called by value. So I should dereference and send it. That's all. Program is ready. We are creating two matrices S1 and S2 and then calling add function for adding them. Then here I am displaying all three matrices, first and second and third. Now let us run the program. Program is running. First it is asking the dimensions of first matrix. So I will give it as 5 by 5. The number of non-zero elements I'll give as 5. Now asking for all the elements. So I will give the elements only in the diagonal. So 0, 0 the element is 1, 1, 1 the element is 1, 2, 2 is also 1, 3, 3 is 1, 4, 4 is 1. So I have given all values as 1. Now it's asking the dimensions of second matrix. So here also I will give the dimension as 5 cross 5 and the number of non-zero elements I'll give 5 non-zero elements. Now here I will give the elements only in the column, the non-zero elements only in first column. That is 0, 0 is 2, 1, 0 is also 2, 2, 0 is also 2, 3, 0 is also 2, 4, 0, all elements I am giving same. Now here you can see that the first matrix is having all the elements in diagonal. Second matrix is having all the elements in first column. Here the elements are in first column. And the summation matrix, summation of these two matrices, here I got the element 3, that is the sum of 1 and 2, and the rest of the elements are as it is taken from first and the second matrix because there are no common elements. Now let me run the program once again and I will give the matrices as diagonal matrices, both of them as diagonal matrices. I'll do this quickly. Dimension of first matrix is 5 by 5 and the number of non-zero elements are 5. Now the elements are 0, 0, 1, 1, 1, 1, 2, 2 is also 1, 3, 3 is also 1, 4, 4 is also 1. Now dimension of second matrix 5 into 5 and the number of elements are non-zero elements are 5. And now I will enter only the elements in diagonal, that is 5, 1, 1 is also 5, 2, 2 is also 5, 3, 3 is also 5, 4, 4 is also 5. First matrix is a diagonal matrix with all 1s and second matrix is a diagonal matrix with all 5s. And the summation matrix, as there are common elements, so they all are added. That's it. So that's all. We have seen the implementation of sparse matrix, that is creation, displaying, and also adding to matrices. So practice this program. In this video, we'll write a C++ class for sparse matrix. I'll give the project name as sparse matrix CPP. And the language, I will select it as C++. Now next, create a project. Here is a main function. I'll clear off all these comments. Now the project is ready. So as we have already seen a program using C language, so there we have used structures, but here we are going to use classes. Now we'll not be focusing on the logic, but we'll be focusing on the style of writing C++ program. So first of all, we need a class for element. And inside this class, I'll make everything public. Element is having three data members, that is first is row number, column number, column number, and the element itself. So I make them public so that they can be directly accessible. Then next we will write a class for sparse matrix. I'll call it as sparse. Now this class should have the data members. I'll make data members as private. First is the dimension. So for that, m, and next is n. And also we should know the number of non-zero elements. Then we need an array of elements. So I will declare element ele. And this we have taken as a pointer so that we can create the array dynamically in a heap depending on the required size. That's it, data members are over. Now inside public block, we will have all the functions or member functions of a class. So first is a constructor. So in a constructor, we'll create or initialize this sparse matrix. So it needs dimension, number of non-zero elements, three things it needs. So first I will take it as m, and next is n, this is for dimension, and the number of non-zero elements, that is num. Now constructor is used for initializing these members. So all these members, I will initialize them here, and the names I have taken same. So I have to use this pointer, this m assign m, and this n assign n. Then this num should assign with num. And num is the number of non-zero elements. So for that, I should dynamically create an array of elements from heap of size num. So here element assign new element of size this dot num. This is a constructor. So here I must have a parameterized constructor only because I cannot take any default dimensions or default number of elements. So I cannot have non-parameterized constructor. Then I will write a destructor. Destructor will delete a dynamically created array. So just say delete and subscript operator, and the array name is ele. Array is deleted. Two methods are over. If you remember, we have written this piece of code as a part of create function. There we were creating a sparse matrix. And in the creation process, we were also taking all the elements. But here, for reading all the elements, I have to write a separate function. So I will call the function name as read, void, read. So let this function read all the elements. So already dimensions are given, just it has to read non-zero elements. So cout, enter non-zero elements. So for reading all non-zero elements in this array ele, I should use a for loop and read all non-zero elements. And for each non-zero element, I need a row number, column number, and the element itself. So using for loop, I'll do that. For integer I assign 0, I is less than num, then I plus plus. And I should see in three values, that is ele of I dot I, that is row number, then element of I dot j, that is column number, then element of I dot x, that is the element itself. See, here I am able to directly say ele of I because this is a member of this same class, that is sparse matrix, and the function read is a member of the same class, so it can directly access these members. This code will read all the elements from a sparse matrix. Then I will also have a function for displaying a sparse matrix. So I will call the function name as display. For displaying, I will display it as a matrix that is with two dimensions. So for this, I will take two for loops. I assign 0, I is less than m, and I plus plus. The next for loop is for j, integer j assigned 0 and j is less than n and j plus plus. Then inside this for loop, I will display an element if there is a non-zero element available for any I comma j. So for traversing through this sparse matrix, I need one more variable k that will keep track of non-zero elements in a array ELE. So if ELE of k dot I is equal to I, as well as ELE of k dot j is equal to j. If they are equal, then I will print the element from ELE. So print the element from ELE of k dot x, and also I'll give some space. And this k plus plus also I should do, as it is traversing a list of non-zero elements, so it should move to the next element. If this condition is not true, then I should print 0. So I'm printing 0 elements also. Then after the end of the inner loop, I should give a new line, that is NL. That's all. And at the end of a class, I should have a semicolon after the end of the class. And all these functions I have written inside the class itself. I have not used any scope resolution. Now here, to use scene and cout, I should use namespaces. So I will say using namespace std. Now the class is ready for some extent. Now the class is ready to some extent. Now inside main function, I will create an object of sparse matrix. And here, the dimensions and number of non-zero elements, I will directly pass them. I will not take them from keyboard. So dimensions are 5, 5 and the number of non-zero elements are 5. Then I should read all the elements. So s1 dot read. So read function will read all the elements. Then I will say s1 dot display. Then it will display all the elements. So up to here we have finished creating a sparse matrix, reading its elements, then displaying an element. So here we are creating it, and here we are reading the elements, and then we are displaying it. So till here, let us run the program and check. In this program, we are not getting a message enter dimensions because already we have given the dimensions 5 cross 5 and the number of non-zero elements are 5. So simply I have to enter the elements. So I will enter diagonal elements. 0, 0 element is 1, 1, 1 element is 1, then 2, 2 element is 1, 3, 3 is also 1, 4, 4, 1. Now I should get a matrix of 5 by 5 with all diagonal elements as 1. Yes, it's working. So till here we have finished. We got a matrix. Display is displaying the entire matrix. Now next thing is I should write a function for addition, but before showing that, I will show you something. So this read function is taking the elements from keyboard and display function is displaying on the monitor. So this read function I can implement it using extraction operator for scene, and display function I can implement it using insertion operator, that is using cout. So instead of calling them as display and read, I will convert them into operators. So I'm going to modify the code. Just watch closely. See, here is a sparse matrix class starting. So for that, again, I will explain you the class from the beginning, then I will convert those functions. See, this is a sparse matrix and these are the data members, and this is the constructor, this is the constructor, and this is the destructor. So here I will close the class. I have closed the class here. So at the end of the closing bracket, I will remove this. I will remove. So class is closing here itself. Now for implementing insertion and extraction operator, I have to follow the rule for operator overloading that is specific for insertion and extraction. First, I will write insertion. I should say iStream and return by reference, and the function name is operator extraction. Then the parameter, first parameter is iStream, call by reference, I will call it as is, then comma, the sparse matrix as a parameter. So sparse matrix by reference as parameter S. Yes, this is the signature for extraction operator, that is iStream operator. It should be same, only the class name, whatever the class that you're using, you have to write down that one here. Depending on the class, this part will change, otherwise everything is same. Now for insertion operator, oStream, return by reference, and the operator name is insertion symbol, then oStream, call by reference, and I will call it as OS, reference variable name, then Sparse, this also by reference. That's it. So these two functions I should implement them. So the first one is for read and second one is for display. So I will change these functions. That's it. This is for read and this is for display. Now one more thing I should do here, I should make them as friend function, because this method of implementation is done using friend functions. That's all. Now these functions, I should change them as these operators. And I don't have to use scope resolution because those are friend functions. So I will write on the same signature here, copy this one, and instead of void read, I'll make it as that extraction operator. Then sparse is S. So wherever I am using the members, I should write S dot, and here S dot num, and element S dot, and this is also S dot. Then instead of display function, I should use this signature and copy it as it is here. See, that signature you have to remember it, right? Now for extraction, this S, so wherever I am accessing the members, I should use that S dot, and here S dot n, S dot element, and here also S dot element, here also S dot element. See, it was so simple. So here I am preferring to show you how to modify the code than to develop the code from the scratch. Because if you are familiar with the logic, then only thing is how to write the code. See, here already I have written one style of code, then I have modified it to another style. Now let us compile now. So that's all, it's ready. My sparse matrix class ends here. It is having constructor, destructor, and two friend functions for insertion and extraction operators, and they are friends, so they are global. So without scope resolution operator, I have written them outside. Now everything is ready. Now same thing should work. Now instead of dot read, I should say cin s1, and instead of display, I should say cout s1. Now let us compile and see if there are any errors. If anything I missed, then I get error, I will remove them. Oh, there is some error. That is, yes, there is an error. See, actually at the end of this function, I should return, because the return type of a function is return by reference of iStream. So iStream reference is is, so at the end I should say return is. And here inside oStream, I should return OS. Let us compile and run. Yes, it's working. Now the same thing I got. Dimensions are already given, so I will give the elements only in the diagonal. So 0, 0 is 1, 1, 1 is also 1, and 2, 2 is 1, 3, 3 is 1, 4, 4 is also 1. Yes, I got the same output. See, there is no change in input and output, only the change is internally inside the program. The style of writing the code has changed. If you look at the main function, it looks very simple, that it looks like as if you have created an object of a sparse matrix. Then you are reading the elements using cin and displaying the elements using cout. And the whole lot of logic is there inside these functions of a class, member functions of a class. Now the next thing is I have to implement add function. So for add function also I will implement operator. So operator overloading in C++ can be done even using member functions or using friend functions. So I will implement it using member function. So here before these friend functions, I will write on the signature for add function, that is add operator. So let us write the signature. Signature is sparse. It will return a sparse matrix, and the function name is operator plus, and this operator actually needs two sparse matrix. So one is itself because it is inside this class, and the second one is sparse. By reference, I will take S. So one parameter it will take, and one is itself. So here just after the class, I'll give a gap, and here I will implement that function. So the same function I should implement it. So I will copy this line. I'll paste it here after the class. Then just before the operator, I should use class name and scope resolution operator. Now I will implement the body of this function. So this function is supposed to add this S with itself. So one is itself, other one is S. So already we know the logic how to do. So already we know how to add two sparse matrices. I will not explain anything. Simply I will type the code. Variables are declared. Sparse matrix for sum, and it is created in heap. The dimension should be same m comma n comma number of non-zero elements of same matrix plus number of non-zero elements of S matrix that is coming as a parameter. One more thing, I should check first number of rows and number of columns are same, that is dimensions are same or not. If m is not equal to s dot m or n is not equal to s dot n, then return null, means it cannot be added. Otherwise create a sparse matrix, already we have done, that is for finding sum. Now I assign, j assign, k assign 0 with a loop. I is less than number of non-zero elements and j is less than s number of non-zero elements. Check if row numbers are smaller or greater or equal. So ELE of I dot I, if it is less than s dot ELE of j dot I, then in sum dot, as it is a pointer, then I should use arrow ELE of k assign with ELE of I, and both of these should be incremented, plus plus and plus plus. Now rest I will copy paste. If this is greater than this one, then in sum copy j, that is s dot ELE of j. Else they both are equal, then check columns. So I will copy the same code and make it for columns. This is j is greater than elements j, then copy the element of I. If this j is greater than parameters j, second matrix j, then copy the element of second matrix. Otherwise, if both are equal, then in sums element of k, copy the element of I as it is. So it will copy I, j and x also. Then x we will make it as sum of first matrix and the second matrix. So ELE of k plus plus assign ELE of I dot plus 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 dot x, and here also in sum also it should be x plus s dot element, that is second matrix, j plus plus dot x. Yes, this for loop will copy all the elements, then remaining elements we can, yes, this while loop will copy all the elements, then remaining elements will copy them by using for loops for wherever I is less than number of non-zero elements and I plus plus, then sum of element of k plus plus is assigned with element of I. Then same thing for second matrix also, and this should be j less than s dot num then this is j plus plus, and this is s dot j. Then at the end, sum number of non-zero elements must be equal to k, and return some matrix. As it is called by value, so we will return the dereferenced value. So the logic is same, only the style of code is different. Just you have to watch it and observe few things, then you can write it by yourself. Now inside the main function, I will create the matrices and I will add them. So I have cleared the main function. Let us write it from the beginning. So this is the first matrix x1. The first matrix, let us say dimensions are 5 by 5 and number of non-zero elements are also 5. Then the second matrix is sparse s2, and this is also having same thing, that is number of non-zero elements are 5. Then I will say cout, enter first matrix, I will take S1, so this will enter the first matrix. Then cout, I will take the second matrix, S2 will take the second matrix. Then I have to find sum of these matrices, so I will say sparse sum assign S1 plus S2. This will add two matrices and the result will be in the sparse matrix sum. So addition is called and the result is obtained in sum. Now I have to print all three matrices, so I will display, say, first matrix NL and first matrix S1. Then cout, second matrix and NL, I'll display second matrix. Then cout, say, sum matrix and NL, this is sum matrix. That's it. Oh, here I have done a mistake. It should be seen, I should read the first matrix and I should read second matrix and run. Yes. I have to enter the elements of first matrix, so that is I will enter diagonal elements and all the values will be 1. 0, 0 is 1, 1, 1 is also 1, 2, 2 is also 1, 3, 3 is also 1, 4, 4, 1. Now in the second matrix elements, I will enter a row element. So 0, 0, I will enter 5, then 0, 1, 5, 0, 2, 5, 0, 3, 5, 0, 4 is 5. Yes, these are the elements of the first matrix that are diagonal ones, and the second matrix, first row is all 5s. Then the summation is, first element is added, that was common, so it is 6, and the rest of the elements are taken as it is. The PDF for this program is given as a download, so you can download it and check it and try it on your machine, practice this program. So that's all. The topic is polynomial representation. And this topic will learn representation of polynomial, evaluation of polynomial, addition of two polynomials. See, this is a polynomial, univariate polynomial. It's a collection of terms with a single variable x. How to represent that polynomial and how to evaluate if you know the value of x, and if there are more than one polynomials, how we can perform polynomial addition. We will learn this. Once we know addition, we can also learn how to perform subtraction and multiplication of polynomials also. Let us look at representation of polynomial. Let us learn how to represent this one. See, this is the polynomial that we write using pen and paper. We use polynomials for solving various problems. Various things are represented in the formulas, that is single variable formulas, that are called as univariate formulas. We use these type of expressions in problem solving. Now the problem is, we want our programs to use these type of polynomial. Then what program should be able to do? Our programs should be able to evaluate the value of this polynomial if the value of x is given, or if there are more than one polynomials, they should be able to add or subtract or multiply them. So first of all, how a program should represent this polynomial, how we will store this polynomial in our program. So for representation, let us observe. See, a polynomial is nothing but collection of terms. So there are total 5 terms here. And in each term, this value is a coefficient. So 2 is a coefficient, 5 is a coefficient. Like that, every term is having coefficient. If there is no coefficient, then it means it is 1. Coefficient is 1. Then next, this x is a variable, but this is a power, that is exponent. So there is one more thing, that is exponent. So this is having exponent 5 and 4 and 2, 1. There is no x here, means exponent is 0. So now I can say that a polynomial is a collection of terms. Each term is having coefficient and exponent of x, power of x. So we can represent a polynomial as a collection of terms where each term is having coefficient and exponent. So I can represent this as a list of terms having coefficients and exponent. So let us prepare it as a list of two things, that is coefficients and exponent. Total 5 are there. Now first term's coefficient is 3 and exponent is 5. Coefficient is 2, exponent is 4. Coefficient is 5 and exponent is 2. 2, 1, 7, 0. So here I have set of terms. This data is sufficient to represent that polynomial. Yes. Then one more thing we may want to know, that how many non-zero terms are there. Suppose if you want to know, then you can have that as length of this one or the size of a polynomial, that is 5. Total 5 terms are there. So this is how a polynomial is represented. Now programmatically, how to represent this one? In a C program, how to represent this one? So for C program, first of all, we will define a term. Term is having coefficient and exponent. So I will define it as structure term. This term should have integer coefficient. See this coefficient value 3, 2, 5, they can be integer also or float also or double also. Depending on the requirement, you can change the data type. And this exponent is always integer type. So I have taken 2 members and this is a term. I am calling it as term. Then what is a polynomial? Polynomial is array of terms or collection of terms. So now let us define struct polynomial. So I write in short poly. Then a polynomial should have number of non-zero terms, that is n, and array of these terms. So now for the array of terms, either I can declare an array of terms or else I can take a pointer and dynamically create an array of terms. So I will take a pointer here. Struct term pointer t. So this is a structure for polynomial. Polynomial is using terms. Now let us learn how to write the program code for creating the representation of any polynomial. Now for creating the representation of this one, I will be writing the code. I will not write any function, right? So in whichever function is suitable, we will put the code there. Just we are concerned how the code looks like for creation or representation of this polynomial. So let us create. See, for creating this polynomial, I need a variable of type this structure, that is poly structure. So let us say struct poly p. Now this p is having 2 members, n and terms. So p is having 2 members. One is n and second one is pointer t. This is for number of non-zero elements and this is a pointer for the collection of terms or array of terms. So I have this polynomial. The first thing that I should know is how many non-zero terms are there. I will take the number of non-zero elements from keyboard. So I will say printf enter the number of non-zero terms. Printf enter the number of non-zero terms. Now I should know how many terms are there and I should read it in this one. So scanf p.n, p.n. Scanf %d ampersand p.n. See, this is an object, so it's not a pointer. So p dot, I can access this member using dot operator, dot n. So here, suppose I am taking the value and the value given is 5. So let us say this is 5. Now I need an array of 5 terms. So let us create this array dynamically. So here I write the code for creating that array dynamically using new operator. So p.t, I will assign array of terms of size 5. So here I write the code. p dot t assign. So I will say new. So new array of terms here. So it is created in heap and its address is taken in p dot t. And what should be the size of that array? P dot n, this size. So here an array of size 5 will be created. So this is an array of size 5 with coefficients and exponent. So this is how it will look like inside main memory. So polynomial is created. See, one thing I want to show you here. See, when I said struct poly just p, so this will be created inside stack. And when you said a new, then this will be created in heap. If we want this also in heap, then I should say new here, and I must take this as a pointer and then say new. So this is directly inside the stack, and this array of terms is in heap. Now memory is ready for storing that polynomial. Now let us write down the code for filling these values. So for filling that, we will take the input from the keyboard and ask the user to enter coefficient and exponent of each term one by one. So already we know 5 terms are there. Let us call this as first term, second term, third, fourth, fifth term. So one by one we ask the user to enter coefficient and exponent. So I should scanf coefficient, scanf exponent. Then next scanf coefficient, scanf exponent. So repeatedly for 5 times. So using a for loop I can do that. So I will write on the code here for reading all those values one by one. So here I gave a message, enter polynomial terms. Now using for loop I'll read the values. For I assign 0, I less than p dot n, that is p dot n and I plus plus. Then here I should read scanf coefficient and exponent. But before that I will display the term number. See, here I am printing printf enter term number. So term number I plus 1. I is 0, so first it will be 1, then next 2. So it will be showing numbers from 1 onwards. So the user who is entering the data will know which term he is entering. So to help him, I am printing term number. Now scanf those two values. So how to read the values? P dot t of 0 dot coefficient dot exponent. The next p dot t of 1 dot coefficient dot exponent. So here I write p dot t of I dot coefficient coef, and this should be ampersand, then comma ampersand p dot t of I dot exponent. So this for loop will read all the values in that array. So here I know the non-zero terms, and here I have created this array. Then here I am reading all the values in this array. So from the keyboard the values are entered, and the values will be like 3, 5, 2, 4, all these values will be entered. So this is how it is represented, and this is the program code. Now let us see how to evaluate the polynomial. Already we have a polynomial p of this structure, and this is how it is having the data. Now how to compute that? If we know the value of x, if value of x is known, then how we can get the single value, that is answer for this polynomial, the result of this polynomial. So if you know the value of x, what we should do? Raise x to this power, whatever the exponent is, then multiply with coefficient, then add with next term. Then in this term, raise x to the power 4 and multiply with coefficient. So every time we have to raise x to this power and multiply with coefficient. So for every term we have to do that, and also we have to go on adding the terms. So all these terms can be computed and added one by one using a for loop. So we have to process all of them, that is depending on the number of terms. So using a for loop I can evaluate this one. So I'll write on the code for this. For I takes values 0, I is less than number of terms p dot n, I plus plus. Now here variable I is not declared, don't worry about that. When I really write the program, that time I will declare the variables. I'm just using them, so focus on the code. Then every time we have to raise x to this power. So this is power x. So assume that there is some variable, we know the value of x, suppose say x is having value suppose 5. This x is there. So we want to place 5 in this polynomial. So for that x, it should be raised to this power. So what is this? P dot t of 0. So P dot t of, instead of 0, I will write I so that I can access all of them one by one. I dot exponent dot exp. So there is a power function available in math.h header file which will raise this x to this power. So x raised to this power. So we got the x power 5. Then that should be multiplied with this coefficient. So this coefficient. So this is p dot t of 0 dot coefficient. So multiplied by p dot t of 0 dot. So after 0 I have to go on 1 and 2 and 3 so on. So let us call it as I dot coef. So this is multiplied with coefficient. This will be for just one term. Like this we have to do it for all the terms in this for loop, and I have to go on adding them. So let us take one more variable and call it as a sum, and this is 0. So here I will write down sum plus a sign. So initially sum is 0. Now this is first term is computed and the result is taken in sum, added in sum. Likewise, every term will be added into sum. So this will be sum assign sum plus this complete product. So here the multiplication is done and this is power, this is coefficient. So with this we'll get the result in sum. Now result is in sum, return result. If it is a function, then return sum. So using a for loop, each term can be evaluated and added. So this is how evaluation can be done. This we will be using inside a function. When I write a program, that time you get the clear picture. Just I am doing explanation here. So that's all about evaluation. Now our next topic is addition of two polynomials. So I will take two example polynomials and I will have this representation ready. Then I will show how two polynomials can be added together. Now let us look at how we can add two polynomials and generate a third polynomial. I have two polynomials here, P1, this is the polynomial and its representation. P2, this is the polynomial and this is its representation. So already I have taken those terms here. Now by adding these two, we want to get this one. So actually we want to add these two polynomials, but our program is having this representation. So it should add these two and get the third representation. Now let us see how to add. So the first thing is total how many terms will be there in this third polynomial. How many terms here? 3. How many terms here? 5. So common terms with common power terms will be added. If nothing is common, then maximum how many terms will be there? 3 plus 5, 8 terms will be there. Maximum 8 terms are possible. If some terms are common power, then they will be added. So number of terms may be less than or equal to 8. So anyway, that I can know only after adding. So I need an array here of size. How much size? Again, maximum 8. So I should take an array of size 8 here, but I already know what will be the answer. So I have taken only 5 here. So you have to take an array equal to the number of terms here plus number of terms here, because maximum that many terms are possible. Now let us see how to add these two. So for adding these two, we need pointer, index pointer, right? Not an address pointer. I on 0 of this one, j on 0 of this one, and k on 0 of this. Like when you add these two polynomials, first term is x power 4. This is also x power 4. So these two will be added. So here, what is the exponent? 4. What is the exponent? 4. So these two exponents are same, powers are same. So add these coefficients. 5 plus 6, 11. So this is 11 and the power is 4. So now the terms are added. So move I to next term, move j to next term, and move k also to next term. Then continue the same thing. Check power 2, check power 3, No, that power is 3. So this polynomial is not having any term with power 3. This is having a term with power 3. So that is greater. So take that one. So it means if the power of this term is greater, then copy this one. If the power of this term is greater, then copy this one. If the powers are equal, then add their coefficients. This is the procedure. So now this power is greater. So copy simply 5, 3. Move j to next term and move k to next term. Compare powers. They are equal. They are equal. So add the coefficients and take the term. So what are the coefficients? 2 and 9. So this is 11 and this is 2. Then when we have added, we should move in both. I is also moved, j is also moved, and k is also moved. Then again check the power. This is 0, exponent 0. Power is 1. So that is greater. Copy that one. 2, 1. Move j. Move k. Now check powers. Both are equal. 0, 0. Then add coefficients. 5 plus 3, 8. 8, 0. That's all. They are added. Then let us write a piece of code for doing this one. I is initially 0, j is also 0, and k is also 0. All are starting from 0. Then we don't know total how many terms we get, so we can't use for. If we know the number of terms, then we can say for these many terms. So we don't know, we have to use while loop. While. How long? Until I reaches this one, means less than n, p1's n, and j reaches this one, that is p2's n. I is less than p1 dot n and j is less than p2 dot n. So if any one of them finishes, then we should stop. And while iterating through these, we should compare them. Whoever's power is greater, copy that one. If this is power, we have to see exponent. So P1's t is of i's exponent. So if I is here, then P1's t of i's exponent. So if P1's t of i's exponent is greater than P2's t of, like j was starting from here, j dot exponent, P2's t j dot exponent. If this is greater than that one, means this is greater than this one, if suppose, then copy this one as it is in P3's t of k. So P3's t of k plus plus also. Afterwards we should move k. Assign with P1 dot t of I plus plus also. Here also after copying we should move I. See, for copying I should copy coefficient and exponent. But I am not saying dot coefficient or dot exponent. We don't have to. Both the values will be copied. When you are assigning a structure to another structure, all the members will be copied in C language. So you don't have to worry about copying each and every one individually. So it will be copied. If this was greater, we copied this one. If that one is greater, we'll copy that one. So I should write on the condition here. Else, if P2 dot t of j's exponent is greater than T1, P1's t of I dot exponent, if that one is greater, then copy this term in this one. So just like same statement, instead of P1 I should say P2 and j plus plus. So here I have written that is in P3 of t of k plus plus, copy P2 dot t of j plus plus. So this term will be copied here. The last thing, final else. Else what we should do? So in final else means both are equal. Both are equal means exponent should be taken as it is, but coefficients must be added, like 5 plus 6 we were adding. So coefficients must be added. So I should prepare two terms of this one, exponent and coefficient. So let me write on this one. So I have to write two statements here. So P3 dot T of K dot exponent. I can copy this exponent from here also or from here also, either P1 or P2. So I will write P1s. P1 dot T of I dot exponent. So this is one statement. So I will use flower bracket. So this is copied. Then coefficients, I should add them. So P3 dot T of K plus plus dot coefficient should be equal to P1's T of I plus plus dot coefficient plus, there is no space, so I will continue in the next line, plus P2 dot T of J plus plus dot coefficient. So in P of Tk of a coefficient, I am adding coefficient of P1 and P2. Two coefficients I am adding. So here I have explained with example and also how the program code should look like. I have written the code also. So this code we will use it in the program. So that's all about polynomials and the representation. Then we will see the complete program on polynomials. In this video, we'll look at the implementation of polynomial. So the representation of polynomial and the evaluation of polynomial and also adding two polynomials. So let us create a new project for this one. I will call the project name as polynomial and the language is C language. Let us create a project. Here is a main function. I'll clear off all these comments, hide the panels. Yes, the complete code is there in front of us. Now, the first thing that we have discussed is the representation of a polynomial. For that, we have defined two structures. The first structure is term, and this term contains coefficient and exponent. Coefficient can be either float or integer, but I am taking it as integer. So first structure is term. Then the second structure is polynomial. So I will just call it as poly. And this should have the number of terms in a polynomial. Then it should have structure type array of terms. And we will take a pointer because we don't know how many terms are there. So I will call this variable name as terms. That's all. This is ready. Representation is over. Now here I will write on a function for creating a polynomial. So function name is create. It should take a polynomial by reference or by address. So struct p, pointer p. Now here inside we'll ask the number of non-zero elements and also we'll take their coefficients and exponent. So first of all, I will display a message asking for number of terms. Then scanf and read the number of terms in p's variable, that is n. Now once I know the number of terms, I should create an array of terms because I have a pointer here. So dynamically I should create an array of terms. So p's terms should be assigned with malloc function I will use for creating array. So for that, term part type pointer and the function is malloc, and this should be equal to the number of elements this p is having multiplied by size of structure of terms. Yes, this will create an array in heap. As I have used malloc function, I should include stdlib header file. So I'll include here. Library is included. Now once the array is ready, I should read all the terms. So printf enter terms. Now for reading terms, I should use a for loop for reading all the terms of a polynomial. So for that I need a variable I. So here on the top I have declared it. Now using a for loop, I will read all the terms. I starts from 0, I goes up to number of terms, I plus plus. Then scanf, I should read two values, that is coefficient and exponent. These terms of I should read coefficient and also I should read exponent. These terms of I exponent. That's it. This will read all the terms. So we have taken the number of terms here, asking how many terms are there, and we created an array of terms of that size, given size. Then we are taking all the terms. That is, for each term we need coefficient and exponent. That's all. Create function is finished. Now let us have a function for displaying a polynomial. Display, it should take a polynomial structure and call by value sufficient because it's not going to modify them. Then I have to display all the list of elements, so I need a variable I, already I have declared it. Now using for loop, I will display all the elements for I assign 0 and I is less than p dot number of elements, because this is called by value, remember this. Then printf, I'll print the term just like how we represent a polynomial, that is coefficient x power exponent. So for that, first I will display coefficient. So for that, first I will display coefficient, then x, then exponent, then plus for the next term. Now first value is p is a term of I dot coefficient, and second term is p is a term of I dot exponent. That's it. After end of this, I should give a new line so that I get some line gap so the output looks good. So just I am displaying a polynomial. That's all. We have a function for create, we have a function for polynomial. So here inside the main function, let us create a polynomial. Poly p1 I will take. First of all, I will call create function upon p1. So address of p1, because it's called by address. Then I will display it. So I will send p1. Let us run the program and test how it takes polynomial and how it will display it. Yes, first thing it's asking the number of terms. So I'll say there are 4 terms. Enter term. So first term coefficient is 2 and exponent is 3. Next is coefficient is 5 and exponent is 2. Then coefficient is 3, exponent is 1, and coefficient is 4, exponent is 0. So the output that we are getting is 2x to the power of 3, 5x to the power of 4, plus 3x to the power of 1, plus 4x to the power of 0. Yes. So this is not multiplication, this is x. That's what we are displaying it here. Now creation and display we have finished. Now let us write a function for adding two polynomials. So already we have discussed that on whiteboard. I will simply write on the code. Function will return a pointer to a polynomial and the function name is add. It will take the two variables of type polynomial. So call by address or call by reference, anything you can send. So I will send it by call by reference. Poly call by reference s2. Add function. Add function is taking two parameters. So then it is returning the address of summation of polynomial. So for that I need one more polynomial, that is poly sum, and it should be inside heap. So I will take it as a pointer. Then first of all I should create this summation polynomial in heap. So sum assign, using malloc function I will create struct poly pointer, and malloc function should take the size of struct poly. Now this is ready. Then inside this I should create an array of terms. So how many terms, at most how many terms may be there? At most the number of terms may be equal to number of terms in polynomial 1 and polynomial 2. It will be equal to the number of terms in these two polynomials. So I will create an array equal to that size. So sum of terms array should be equal to struct term pointer. Here I am creating an array equal to the size P1's number of terms plus P2's number of terms multiplied by size of structure of term. Yes, this will create an array. Now I have to scan through two polynomials and also generate summation. So for that I need three for loops. So for that I need three variables I and j and k. And these three variables must be initialized with all zeros. I, j and k, all three of them are zeros. Now as we have already seen that using while loop we can scan them and we can copy the elements. So I will quickly write on the code while I is less than P1's number of elements and j is less than P2's number of elements. Now compare and copy. For comparison, if P1's terms of I dot exponent, if that is greater than P2's term of j exponent, means first one exponent is greater than that one should be written in sum of terms of k plus plus should be copied with P1's terms of I. So if first one is greater, we'll copy the first one. Otherwise, if second one is greater, we'll copy the second one. So I will copy this code and I will modify it for second term. So if first polynomial is greater, this is greater, I'll just change the sign and I will say if it is smaller than second polynomial's exponent, then copy the element from second polynomial. So this should be second polynomial and this should be j, and also it should be plus plus, and here also it should be I plus plus. Yes, if first one is greater, copy that one, otherwise copy the second one if second one is greater. Now finally, else, it means if both of them are equal, then I should add coefficients and exponent should be same. So summation of terms of k dot exponent should be same as P1's terms of I dot exponent. So first I have finished exponent, then let us take coefficient. So terms of k plus plus I will do dot coefficient should be equal to P1's terms of I plus plus I will do dot coefficient plus P2's terms of j plus plus dot coefficient. That's all. So this loop will be comparing and copying them. Once it has came out of the loop, there may be some remaining elements either in first polynomial or maybe in second polynomial. So I should take care of copying all those elements while I is less than P1's n and I plus plus. I should copy that elements of first polynomial in terms of k plus plus P1's terms. Then same way I should do it for second polynomial also. So I will copy it and paste it here and modify this one. This is from j and this was P1, so this is P2 and this is j, and sum of terms k plus plus assigned, this is P2's terms. Yeah, I missed this I, and this is j. Yeah, addition of terms is finished. Now sum's number of elements should be equal to k. Then also return sum. That's all. Addition function has finished. It's a little lengthy. You have to practice this one. Now let us create two polynomials. So P1 and P2, and also for addition I will have a polynomial that is P3. Now here first we are creating first polynomial. Then we'll do one thing. We'll create the second polynomial also, that is P2. After this we will call add function and take the result in P3. P3 assign add address of P1 and address of P2. Then I will display all the polynomials. So I will not write any message, just I will make sure that it comes in new line. So /n, the first one, and after displaying first polynomial, again I will say printf, that is /n, that is new line, and call display function upon second polynomial. Then again a new line. Then I will call display upon third polynomial, and it should be dereferenced and send, that is P3. That's all. Number of terms. I'll give 3 terms for the first polynomial, and the terms are, first is power 5, power 3, and power 1 I'll give. So coefficient is 1 and power is 5. Coefficient is 1 and power is 3. Coefficient is 1, power is 1. Then second polynomial, this also 3 terms. Now power 4, 2 and 0 I will give. Coefficient in 1, power is 4. Coefficient is 1, power is 2. And coefficient is 1, power is 0. Yeah, you can see that the first polynomial is 1 into x to the power of 5 and 1 into x power 3, x power 1. This is 4, 2, 0. When addition is done, I got all the terms, that is 4, 3, 2, 1 and 0. Let me try another. Again I am running. The number of terms are 3 only. So first one is coefficient is 1 and exponent is 3. Then second one, coefficient is 1 and exponent is 2. Then third one is coefficient is 1 and exponent is also 1. Then for this also I'll give 3 terms for the second polynomial. Now the coefficients I'll give them as 5. And the first power is 2. Coefficient is 5, second power is 1. And next is power 0. Now you can see that 2 terms are overlapping, that they are having common power 2 and power 1. Let us see what happens. This is the first polynomial, that is power 3, 2, 1. Second polynomial is 2, 1, 0. And here 3 is with coefficient 1. And 2 and 1 are having coefficient 6, because this 5 and 1 is added. This 5 is added with this. This 5 is added with this 1. And the last term is just 5x0, that is 5x power 0. That's all. So this is working perfect. So you can try this program. You can find the downloadable file below the video. So if you want, you can verify your code in the PDF.